Yeah, I
The
mean, that's all the formulas are laid there on a table. But what do you mean? I guess is probably a better question.
no, that was like if it's always going to be the same number
Oh,
to
it's
get.
not. It's two,
Oh,
a little bit different, but
okay.
it's not here. Not for dichotomous. Are you guys seeing my slides, by the way? Yes.
Yes.
So now what we're looking at is dichotomous outcome. And this is one sample. So the formula for n is given by the following. And I didn't derive it. I don't want to waste everybody's time. The derivation's messy. It's not too bad. By the way, this time the margin of error is a percentage, right? Because remember, we're looking for confidence interval within some percentage. So let's say that we want it to be 50% with a plus or minus of 10%. So our margin of error is 0.1 because it's 10%. Because remember, the margin of error is saying the spread around that percentage because dichotomous is a percentage. If you do not have preliminary data, assume P is 50%. What's the worst that can happen? I'm wrong. Then I get preliminary data and then I redo this calculation, but you're not going to be off by much. So if they don't give you a proportion or any preliminary data, 0.5. Notice, is there any standard deviation in this formula? No, because it's proportion. Okay. So I made up an example because I'm a nerd. So let us say that you're surveying people in a housing unit that has 340 occupants, where the average age is 38 years old. You're curious about getting a gym installed, but want to have a high confidence with a small confidence interval. You do a preliminary survey of 10 people, and 8 out of 10 said they want to get the gym. How many people do you need to survey to get a 95% confidence interval within margin of error of 5%?
So P
You're
is
gonna do no, no,
population
you're gonna do
size.
this in groups. In
And
groups.
I feel like we work better as a class.
No, because not everybody participates. It's the same four people.
Okay.
I want you
Shoot,
to
I like
try.
participating in a class as well.
What?
I like participating in a class as well.
We will though, won't we?
Yes,
I want you to
that's
try
fine.
it first. I'm only going to give you 4 minutes. Get as far as you can, okay? So you're on a time crunch this time.
Hmm.
Man. Okay, rooms are open.
Okay. I love this class. I didn't think I would like this class so much.
I don't
It's
I don't like this class because
it
I don't know how to use the software, so I'm always writing stuff by hand.
no, my brain's cracked open, don't get me wrong, but I'm just like, oh, cool. And everyone's so smart. I love it. Okay.
Wait, he didn't we don't have the question. Wait, it's
It's
on the PowerPoint, it's on the slides.
Oh,
yeah. Let me go to the slides. One sec. I did download it.
Yeah. So I know the pop
Hmm.
yeah, that's the
Yep.
mm-hmm.
Hmm. Okay. Yeah.
What is the what so I know the other number, but what is the margin of error then? Oh,
Yeah.
percent. Oh, so it'd be in. Oh, he gave us the question. So it'd be n equal 340 parentheses 1 minus 340 parentheses parentheses 1.96 divided by, you said 0.05%,
Mm-hmm.
parentheses squared, and that'll be n. But Anna, can you show me how to do our studio again?
I don't hear talking.
Oh,
We're thinking,
we did it. It's n equal 340 parentheses 1 minus 340 parentheses z. I mean point 1.96 divided by 0.05 parentheses squared.
Okay,
Right?
we
No?
shall see.
he said we shall see. Okay.
Hey, listen, you're gonna get mad at me, but I want you guys to be wrong. It's a good thing.
Okay.
What's the stakes if we're wrong in this course?
That's true.
Besides you guys like wanting to throttle me half the time. Yeah.
Well,
Talk about okay, I will give you advice. The P, should P be a number? That's my question.
should P be a number?
You have 1 minute left.
Oh, I don't even have a question.
Yeah. Well,
I say P should be a number because then say the population size was 300
mm-hmm.
proportion our population. Oh yeah.
Yes. Yep.
I was
Yep.
about to say what
You're right.
Oh,
80% of the 340, which would
40.
be
Did what did you say again? What is it? You said it's what? It's 80% of the 340? 8 out of 10. Huh.
okay.
Yeah.
mm-hmm.
And that's the expected.
80%.
Mm-hmm.
I think we're all back. All right,
Mhm.
let's do it together. See where we're at. All right. So we have this example. I'll call it the Hibden example. Is that okay? And what's the first thing we ask ourselves when we see any problem?
What type of data is it? Mm-hmm.
And what type of data is it?
NUS? Independent sample.
Independent.
Categorical.
So are we in categories? Are we working with proportions? Are we working with averages?
Proportion.
Portions.
Yeah, independent, dichotomous. So remember, everything we're working with is percentages, right?
Mhm.
Okay. So what's the formula we want to use? Or what's given, I guess. Yeah, let's do a formula first, because I always do that. What's our formula?
N equals Z squared times P in parentheses, 1 minus P, close the parentheses, all over margin of error squared.
Yeah, I'm gonna do it this way if that's okay. But what you said is completely correct. So what do we know? What's P? What's Z? And what's E?
Use the preliminary data, 8 out of 10.
Okay. But I think the other group had a different value. What'd the other group get?
You said it was the margin of error, right?
No, P is your proportion.
Oh, oh no.
No, you're fine, you're fine, you're fine.
Yeah, I thought we were looking for E.
Well, what is E then?
The margin of error,
And what do
which
we
is
want that margin to be?
0.05.
Yeah, that 5%, right?
Mm-hmm.
And what do we want Z to be?
1.96.
Yeah, because it's the 95%.
95%.
Yeah, very good. But what, so the other group, you had a different P value. What do you have?
We were thinking population, so at first.
Ah, yeah. So you were thinking 340,
Mhm.
but yeah, recall that P here equals the proportion.
I do have to say that the brilliant members of my group realized the mistake and fixed it.
That's awesome. See? And you will probably never forget now.
Nope.
Okay, I don't like working in fractions, so I'm going to write this as 0.8. Is that okay?
Yes.
All right, let's plug everything in into the formula. So n equals 0.8 times, what's 1 minus 0.8?
0.2.
Point.
Mhm. All right, so what do you all get? Yeah, I got you. I see that.
245.86. We rounded up to 246.
Anybody else? Okay, I'm just assuming you all agree. That's okay. Let me share my screen. Because I actually did this problem on the slides too. And I just want to say, we need 246 residents of the housing unit. However, people are not impressed and wanted it to be 99% confidence interval with a margin of error of 1%. So you go to this board. Okay, I've never lived in a condo or any of these. I've only lived in apartments until recently. So you go to this condo board, you're like, well, they're like, no, 99% because we're going to be spending all this money to put in a new gym. And not only that, we want that margin of error to be only 1%. And the question is that even possible? Well, let's look at this. If we put in those numbers, the Z value changes and the E value changes, we're going to get 10,000 people. Is that
Mhm.
possible?
Mm-mm.
No, your unit's only 340. They're playing a game. They probably have a mathematician, a statistician there that's like, haha. To be honest, that's what I would do if I didn't want to spend the money. It's like, I'm gonna push the boundaries a little bit just to mess with you. Right. So, and by the way, this is a simple problem, but I actually had a colleague who was on a condo board association. This was like 15 years ago. And he played this game, and I was like, that's totally messed up. It's like, It wasn't this exact example, but it was basically that it was impossible to get a survey that would agree with it. Okay. Questions on this?
Yes. When would you use this in like a real, I know you the condo example, but like if we're doing research, like when would we use this?
Yeah, so remember that proportions are really important if you're looking at what percentage of people get sick, right? So let's say I give patients a certain drug, and 30% of the time the patient has allergic reaction.
Mhm.
Okay. The question is, now I'm going to introduce a new drug where we're guessing it's about 20%, and we want to know how many patients we have to test it on. Does that answer your question?
Yes, it does.
Mhm.
Housing is like a big one too. Like proportions and housing occur all over the place. So now what we want to do is talk about dichotomous and two samples. This is the most complicated formula. Again, what we're looking here is two different proportions. Anant, go ahead. Well, we don't need to really. 340 and like the age was just like a red herring. Well, the question is, how many people do we need to agree with us to get the gym? And the thing is, like, if they move the goalpost, the 340, that's when it really comes in, is like if 10,000 is impossible, right? It doesn't matter. It doesn't like because I could have said that we're doing an apartment complex, one of those giant ones that has, 500 people or 1,000. It wouldn't matter, right? Because it never affected what we needed. You're welcome. Because remember, you're not trying to see if you're going to get that 80% that you want. You're just trying to see if you're within some margin of error of with what people say yes to do. Okay. So here we have two different samples, and we're looking at the difference of these two different proportions. Okay. And the formula looks complicated, but it's really not. We're just adding that P2 term to our equation. Again, I'm not going to do an example here because we need to move on to the hypothesis testing. But again, what have we done every time? Identify the data, identify what the values are, plug it into the formula. And then have a statement at the end. Have a legitimate 1 or 2 sentences describing what the results mean. And remember, mathematicians can get away with saying the answer's 2 or 2/10. I mean, reality, we shouldn't. But in public health, we can't, right? We have to really state what the results mean. Any questions about sample size calculation for confidence intervals? Remember, I can't see you all, so.
No questions.
By the way, these calculations seem pretty straightforward, right? I hope. Identify the data. So what we're doing next is, let's go. So what we're doing here is now we want to estimate the sample size for hypothesis testing. What we just did was for confidence intervals. But to do that, we have to kind of recall stuff. And I want to recall that when we were doing hypothesis testing, we have 2 types of errors, right? We have type 1 error and type 2 error. And the alpha value that we always calculate of 0.05 protects against type 1 error. But to protect against type 2 error, we have this beta value. And And when we do hypothesis testing, a lot of times we're working with sample sizes that might be very small. And so we want to understand what should be the end so that we're protecting ourselves. And we're going to talk later about power calculations and all this stuff too. See? So instead of beta, we use this concept of power. And so we say it's 1 minus beta. So thus, this is the probability that we test correctly, the correct test rejects a false null hypothesis. Okay. So what we're saying is the test correctly says the null hypothesis is false. That's what 1 minus beta means. For a hypothesis test, what we want is small alpha. So that alpha is 0.05. And we want large power or small beta. Okay. Because remember, power is 1 minus beta. Basically, you want alpha to be small and beta to be small. But you can't have both. So alpha and beta are related. When we increase alpha, we decrease beta. Thus, we have to find this balance. Power, the 1 minus beta, is related to variability in the data, how much the data changes, and to what we call the effect size, which we're going to see later in like in 2 slides. The effect size basically relates to how much error we're seeing. The typical values of power are 80% or 90%. I think in almost all the examples in the book, it's 80%. And some of the research I've done, we've always done 80% as well. Well, alpha, we've been using 0.05, 95% confidence. So what we're going to start with is a 1 sample continuous. The calculation for our sample size really depends if you're doing a 1-tailed test or a 2-tailed test, right? If we're just saying there's a difference, or if we're saying it's bigger or smaller. So the book, in the analysis of the book, they do a 2-tailed test. So what I'm providing you here is a 1-tailed test. So I want you to have both sides so you understand the difference, okay? And the book does this well. The last 3 chapters of the book that we've been going over are great. I keep mentioning, I use them. When I was doing research over the summer at Brown, doing data analysis, I brought this book with me. Okay. So I really think it's a good guide and to keep with you as you're doing other stuff in your other courses. So let's say that we're looking for that the alternative says that we're going to see a decrease in our average. So our N is calculated by the Z value for alpha and the Z value for beta divided by this ES. And we'll tell you what ES is in a second. And then you square. Looks very similar to what we just saw for N, wasn't it? Because of Z times sigma over N or over E, sorry, squared. So that ES is known as effect size. And what that's basically doing is you're taking the difference of the mean calculated by the experiment and what is expected. So for the alternative. So basically you're taking into account what the mean is for the null and the mean for the alternative. And you should be like, how do I calculate this? Well, it comes out in the problem. So somebody can read example number 7 in the book. Somebody new.
What page is that?
189.
1 second.
189.
Okay, the mean is that the mean body mass index, BMI, for boys of age 12 years is 23.6 kilograms per meter squared. An investigator wants to test if the BMI is higher in 12-year-old boys living in New York City. How many boys are needed to ensure that a 2-sided test of hypothesis has 80% power to detect a difference in BMI of 2 kilograms per square meter. Assume that the standard deviation in BMI is 5.7 kilograms per meter squared.
So a lot of information there, isn't there?
Yeah.
Yeah, Zahara, and I thank you, by the way. I appreciate it. So where should we start? What's our first step?
I would guess that it's two two independent samples of data,
Why do you think that?
because one set is going to be 12-year-old boys living in New York, and one set is going to be 12-year-old boys, I guess, in the world, but in general.
Okay, so this is where we and I'll help. Thank you, Kelly. So typically that's how it'd feel, right? Because you're comparing. But remember the world numbers, when we do hypothesis testing, we're comparing one value to something else, aren't we? So we're just working with 12-year-old boys first. So I agree, it looks like it should be two independent. But it's really just one. So this is where like really thinking about how calculations work and that hypothesis testing, you're saying we have a number. I'm now going to go out into the real world. Real world, we're always in the real world, but I'm going to go out into a school, work with these 12-year-old boys, and I'm going to see, do we see a decrease or an increase relative to what it has been shown for the whole population? So Kelly's on the right track, but the problem is with hypothesis testing, we have to recall that you're taking experimental data, comparing it to a larger data set. So it's not really this. It's continuous because it's average. But I agree, like Kelly, the first time I see this, I kind of think that. Then I have to recall what hypothesis testing is. Even I, the professor, get confused. So, okay, so what information is, or what, we can write down the formula first because I think that's easier.
N equals Z1 minus alpha plus Z1 minus beta divided by ES squared.
Okay. Does that make sense? And my alpha kind of looks funky, like a funky monkey. Okay.
Do you need to do the equation for the effect size too?
Yes, yes, we do, because that equation changes. Help me out.
Oh, you want somebody? Oh, um, you want one of us to say it?
Yeah.
Oh,
Memorized.
Um, it'll be the brackets,
Yeah,
ES
this is absolute value.
absolute value. And then what's the U?
Mu.
Mu1 minus mu0, and then the bracket again, divided by the standard deviation.
Okay. So a lot of information, right? Just confidence in a one-on-one is straightforward. It's like boom. But when we get into hypothesis, it does get more complicated because you're doing comparison, and there's a lot of power in doing comparison. So what information is given?
Well, the beta size is 80%.
So beta equals 0.80. Keep going.
The standard deviation is 5.7.
Okay.
The test difference, the difference would be is 2. So would that be
We'll talk about that.
Oh.
Yeah. Good. What else are we missing? Again, some of the information we're going to get out of the paragraph might not be necessary, but it doesn't hurt to write it down.
we need the Z value?
Yeah, we'll get there, but they don't give it to us, right?
Mm-mm.
How about alpha?
Would alpha be 0.05?
Oh
Yeah.
yeah.
Yes. Okay. Do they give us mu1 and mu naught? Do they give us any averages?
It's a
26.
Well, I didn't hear. I'm sorry. I didn't hear what was that?
The mean is 23.6.
And is that the mean for the whole population or the 12-year-old boys?
The 12-year-old boys is 23.6.
So it's mu naught. Okay. And do we know mu1 for the whole population?
No, they don't say it.
Okay. So cool. So when approaching these problems, the first thing you want to do, what do you think the first thing we probably want to calculate?
sample size, the population.
Yeah, that's our goal. Our goal is to actually calculate n. You're correct. So we have to calculate n, but notice what is in n that we need to calculate first. We have another formula.
Effect size?
Effect size, yeah. So first thing, calculate the effect size. And the reason you want to do that first is because you're going to need it to calculate n. So again, we have the formula, and I like writing things down again. But the cool thing is this piece right up here is our test difference. So we don't even need to know what mu1 is for the whole population. We just want to know if we're within 2. So the effect size is 2 over 5.7, which is approximately 0.351. Next, we want to calculate n. So n equals Z1 minus alpha plus Z, and this is over 2, by the way, because it's doesn't matter if it's up or down. Well, we know the Z value for alpha is 1.96, and that Z value for the 80% is 0.84. So this is Z of 1 minus 0.8. Or, sorry, it's not true. This is for Z of 0.8. Okay. And then we divide by 0.351. We square it. And you're going to get this to be 63.64. What does that mean? What should N be?
Rounding up,
So we should have at least how many children?
before.
So we have sorry, it's a long sentence. So what we're saying is we should have at least 64 12-year-old boys in the study to have an approximate test difference of 2 from the national value. So the answer is really 64. Yeah, good job. Okay. Questions on what we just did?
No questions.
Yeah. Yes. So now if we have 2 independent samples, notice the calculation is the same except for multiplying by 2. Why are we always multiplying by 2 for 2 independent samples? Is because you have 2 different populations. So let's say you get 100, I'm gonna put 50 in one getting the drug and 50 not getting the drug. So it doesn't change much. For 2 match samples though, it does change a little bit because your effect size has a different value, is a little bit different. So your effect size is the difference of our average over the difference, the standard deviation difference. So let's do an example. We're not going to do it in groups just because of time and because you guys already yelled at me that you prefer us doing it as a class. But I need more participation. You're going to be stuck doing it in groups.
Got it.
I'm teasing. All right, somebody want to read problem 8 on page 190.
An investigator wants to design a study to estimate the difference in the mean BMI between 12-year-old boys and girls living in New York City. How many boys and girls are needed to ensure that a 95% confidence interval estimate for the difference in mean BMI between boys and girls has a margin of error not exceeding 2 kilograms over squared. Use the estimate of the variability in BMI from problem 7.
Yeah. So now what are we doing? So we're looking for we're basically comparing male and female. Is that correct? Or those that identify as male, those that identify as female?
Yes.
Mhm.
So what we're gonna do here is, what's the first question we always ask?
What type of data?
What type of data is this? Is it independent or matched?
Matched.
Okay, why do you think it's matched?
Because we're asking the same question just in two different populations.
Are they the same population?
Oh, no, they're not the same population.
So are they independent or matched?
They're independent.
Yeah, it is confusing. Like literally, but this is like the process. Yeah. And even myself, like I keep reiterating, I make this mistake. So this is independent.
Okay.
So for the homework, if we was to use the wrong equation, but for the answer, but got the answer right for the equation that we use, will we lose points for that?
What do you think? Yeah.
I love that you
Remember, I
asked.
only grade 2 of your or 3 of the problems. I have a different grading scheme for you all versus my other class, so I always have to recall. I only grade some of them. So if you attempted it, a good faith attempt, you get points,
Mhm.
right?
Yeah.
I still give you feedback even on the problems that I don't grade. Okay, so it's independent. So let's write down our N, our formula, and I'll do it for us. But I need you all to give me values. I don't even memorize this. Okay, so what do we got?
So we're supposed to use the exact same data from problem 7.
Mhm.
Well, what data do they give us in problem 8 is a better question first. Even if
The
it's worthless, what data do they give us?
the confidence interval and the margin of error,
What was the confidence interval?
95%.
So we know that's related to the alpha is 0.05, right?
Mhm.
And what was the margin of error?
2.
Yeah. Equals 2. So really everything's the same, isn't it?
Mhm.
I'm not going to go through it, but notice that this is 2 over the same sigma that we had above, 5.7. So nothing's really changed, has it? Except for me not squaring things. Has anything changed?
No,
No.
just multiply everything.
We're going to multiply by what?
2.
Two.
So n will be, excuse me, 2 times 63.64. And
We
what
don't
is that?
You don't do 2 times 64.
Well, let's see what happens. But to be yes, I will. But I know that number in my head. I have to give you all a little work to do.
127.28.
Yeah, it's the same thing, isn't it? So we need 128. AKA
Mhm.
we need 64 boys and 64 girls.
Yeah.
Not boys. So it didn't change too much, did it? It's kind of funny that even though we made the problem a little bit more complicated because we're right, we
Mhm.
it's the numbers didn't change.
Mm-mm.
Okay, we're almost done. Next, we want to look at one dichotomous one sample, and then obviously dichotomous independent samples. Same process. Remember, it depends if you're doing one-tailed or two-tailed. The book is always doing two-tailed. My formula that I've been giving is one-tailed, so it doesn't change much. Their z value for alpha is a little bit different. That's all. The effect size here is given by this calculation. P naught is the proportion known is known, or it's some historical value. And P1 is the proportion under the alternative, right? Remember, that's what we're measuring as P1. For two independent samples, what we have for dichotomous, the calculation is actually a little bit easier. It's 2 times that calculation for n, but this time the effect size has a little bit different. Here we're taking the difference of P1 and P2, and that overall P is there's a formula for that overall P that we use for confidence intervals and hypothesis testing before. So it's not much different. Okay. I wanted to do this example, but I think we're going to end here because I think you all have some more questions. Okay. Is that okay?
Mhm.
Because I wanted to give plenty of time. I'm starting to run out of
Are we gonna have homework from these practice problems? Because I feel like the practice problems you give in class are easier than the ones that we have for homework.
but they're from the book. They're the same
Oh,
problem.
you should do the harder ones in the book and give us the easier ones.
I've chosen harder ones.
Okay, so everything else is gonna be easy.
No, that's a lie. Come on, do not trust me. Do not trust that. No, I mean, I have to use some easier to get the points across, right? Unfortunately. But I do give ones that are they're equivalent. The problem is it looks easy because I've done it, right? And I'm guiding you. And the hard
Mhm.
and to be honest, there are many times you're sitting here like, now I'm doing, but how am I going to do this? I actually do this with my research when I'm coding, and when I'm sitting there with my colleagues and coding together, it flows. But I'm sitting and trying to do it by myself. It's like, where do I go?
So
Right?
basically, we should all do our homework together.
I don't have a problem. You should be collaborating. I expect
Yeah.
the work to be different, right? And
Mhm.
your sentences and your answers should be different, but you should collaborate. Actually, I think I say it in the syllabus. Collaboration is a good thing.
I'm writing an email now to the group.
Yeah.
I want you guys to work together because you learn better by talking it out, don't you?
Yeah.
And asking questions. Don't just say, "Oh, I get it." If you don't get it, ask because you're gonna have to do it on your project. Right?
Mhm.
That's where the individual assessment is. By the way, Tiara, I want that Coke so bad right now.
It tastes so good.
You're killing me. All right. Questions related to the assignment. So Tiara asked the big one. Yes, please collaborate. Please work with each other.
So we have the assignment for confidence interval and hypothesis test is due next Thursday. Do we have
Mhm.
that's the only thing we have to work on?
You will have a discussion
Mm.
because we won't have class. But the discussion is again, give us a new paper related to your project.
Okay, and
Because
For
because
that
it's because remember
project,
we're setting ourselves up for the project too.
for the project, so if I wanted to do the same thing as I did in the first one.
Yes, I want you to.
We're allowed to like, to use that paper and like start, just add to it.
Yes,
okay,
please.
But of
Actually, it
course,
says
we
it. It says
revise.
this in project 2, the write-up says, I encourage you to. So really look
So
at what I'm
I could
expecting
just
you
make
to
those
do.
parts of my paper better, but not necessarily change them and add in like data section.
You're adding some more data analysis, and to be honest, I'm looking at if you're making the corrections that I wanted from you.
Oh, of course, yes. I'm not gonna like, yeah, I got it. Thank you.
Yeah, so to reiterate, as Zahara was asking, which is a great question. And I said, and look at what the write-up expectations for project 2. Please, I encourage you. If you want to change, it's totally fine too. Because to be honest, that's what I would probably be doing always, because I can't, I like the pain apparently. But if you're comfortable with your project you're working on and you can do this data analysis that expected, stick with the one you did. Make it a better write-up, make it a better presentation. Okay? Other questions?
so I'm sorry, the hypothesis is due next Thursday as well?
Yeah, yes.
Okay, and where do we find that information?
D2L?
All right, I guess it was a stupid question, but
No, it wasn't a stupid question. I'm just
I feel like I'm so lost. Okay, I will find it.
somebody want to help her?
Oh yeah, it's in the assignments, and then I had a hard time finding it too. But if you scroll up, click on assignments, and you press another link, and then it comes down.
Ah, I see assignment 2, assignment 1, assignment 2, project 1, assignment 3.
I clicked. You got to click on assignments, and then I just did it, and then I went to assignment 3, and I clicked on assignment 3.
Okay,
He kind of has it in the description, like there's no particular file to download.
it's what?
It's in the description of assignment 3.
Yeah.
Okay,
And this
got
was
it.
actually how it was done in assignment 2 as well. And assignment 1.
Okay,
We just forgotten because it's been so long.
I think so. Why? Thank you, everyone.
No, that's team effort. What's it? Team makes the dream, whatever.
And then again, for assignment 3, I can send an Excel sheet as well.
You can, but
But
remember
also,
these solutions are expected to have complete sentences.
Mhm.
okay.
But I do want to see your Excel sheet if you use Excel. And it says it in there. Oh, by the way, a few of you have emailed each other, and Maricel is not here, but we should give her a big shout out because she looked at the assignment. She's like, I'm a little confused. How am I supposed to get the presentation from my colleagues?
Mhm.
Like, I didn't take good notes for that day. I was like, hey, that's a good point. I was like, email them. And so I modified it based on her recommendation. Actually, we were emailing back and forth multiple times. She's like, that sounds right. So reach out to each other. And already a few people have done that. Please. We did. Not all of you, Zubia. You don't know that. Maybe all there. You kept me out of the loop.
I emailed Chelsea and Sierra.
Yeah, I
I was
saw
about
that.
to email the whole class if anybody didn't answer me.
Yeah.
Yeah, I apologize. I'm in the middle of
And
something.
I'm not throwing shade. I'm not throwing shade.
Sounded like you were. No, I'm teasing.
I'm just aggressive in my wanting to presentation.
That's good. So I'm glad you emailed 2 people, Zubia. Other questions?
I
I have
guess
office hours Tuesday. I
for
have
every
office hours
answer,
Wednesday and Thursday. Go ahead, Tiara, though.
for the answers you want to write up, but I did math by hand. Should I just take pictures of my notes?
Well, yeah, I'm assuming yeah, you scan it. You want it to be as one PDF. Do you know how to scan with your phone?
No, but I figure it out.
Yeah, it's through the notes application. It's super easy.
Okay.
I didn't even know that. I actually have like Adobe Scan that sucks. So I'm doing that
Yeah,
from now on, Chelsea.
you just go in notes and um, you press the three dots on the upper right-hand side, and there's a little scan. It's scan.
That's awesome.
It is so awesome. I use it all the time for work.
Okay.
I may not be able to find assignments, but I sometimes come through with technology.
Okay. I'll have to figure this out. But there are like free apps, and I have like an old crappy phone. So, and to be honest, if my undergrads can do it, y'all, be great. But if you're still having an issue, let me know. But please submit it as one PDF.
Okay. Did you say it inside? It's in our phones in the notes.
Yeah. Yeah. So you just open up notes
Mm-hmm. Hit the three
and
dots.
and then go on the three dots in the upper right hand side, and it says scan. There's a scan option.
You can share your screen if you want to show.
Oh,
Or
you know what? I probably have to it's on my phone and I'm on my computer with
oh,
but
I'll figure it out.
you see that?
I don't see it in my notes. You're fancy.
Yeah.
Oh,
I don't
maybe
I don't see it on my
let me
phone
see.
either.
Okay. Go create a new note. Wait, I know it can be done. Create a new note
Mm-hmm.
and then press the three. Oh, no, I have to figure it out how to do it this way. I swear to goodness it is possible. Okay. Create a
Oh,
new note, click on the photo,
Wait.
and then it's scan.
Yeah, I got it.
That is so cool.
Yeah, and you can scan multiple pages and to create one document.
Mhm.
Wait, click
Thank
on the
you.
what? Click on the, oh, what am I clicking on?
Hmm?
After
Click
the
on
notes, after.
the attachment at the bottom right here.
Oh, okay.
Yeah, it has like a
Got it.
camera icon,
Yeah, I see it.
and it should say scan documents.
Oh, shoot.
Notes is awesome. Thank you so much for sharing.
Yeah, absolutely. Of course.
Other questions about the otherwise I'm gonna go sleep.
I'm gonna write an email to everybody inviting people to come to a study group this weekend.
And over the weekend, if you have a question, I will be grading. It doesn't mean I can answer right away because I have also doing a birthday party for my son. But I will try to respond within 24 hours. And if I say, this is very complicated, I cannot answer this via email, I apologize. But I will do the best I can, okay? But if you take screenshots of what you tried to do, oh, thanks, Maya. If you take screenshots of what you tried to do, right? That's much easier for me because I can pull it up and put it in my tablet and like write stuff on it. Okay.
Mhm.
So this is what we try. This is what I tried, or this is what we tried. It's not working. What are we doing wrong? Okay.
Okay, one more question. The discussion that we have is not due Thursday too, right?
The discussion, it's due Thursday, but I can push it into the weekend.
That would be awesome.
Is that okay?
Yeah.
Come on, you guys are grad students.
Yes, that would be great because I'm still working on the second half of the last of the assignment.
I think you're ahead of the game. All right. Help each other out, please.
Okay.
Learn from each other. You all have different skill sets and strengths and weaknesses. Some of you are very good with the computational tools. Some of you are good about translating it and understanding it. Okay. Okay. What is it? The teamwork makes the dream work. There we go.
Mhm.
Hey, it was good to see everybody. And thanks for the active participation today.
Thank you for the class. I mentioned it in the breakout group. I'm surprised how much I'm enjoying this class.
That's good.
My brain's broken, but it's really fun. And you
Yes,
guys are so
that is my
smart.
goal. Break your brain, have fun.
And my fellow students, y'all are so whip smart. Oof.
Yeah, you all are very smart. And to be honest, this is a weird class. It is a weird
Yeah.
class. Not you as a class, but just
Oh.
no, not you as students. You guys are great. It is just, it's a weird topic because you all have different strengths and weaknesses in mathematics and statistics
Yeah,
and
my weakness,
computational tools.
my weakness is software.
That's okay. But I think you have strengths in other areas that can support those that have those weaknesses in the areas you're strong in. Have a good night, everybody. I'm gonna load these
Thank
notes
you.
up now, okay, before I go to bed.
All
Bye,
right. Thank
everyone.
you so much.